Okay, now, before we just start to do some kind of simulation and understand the concepts of the posterior predictive distribution and how we can just use that intuition into some actual real simulations of our original datasets, we need to just install two packages, which they give us some kind of graphical capabilities in order to just view and visualize those simulations. The first package that we have to install and have it ready by the library commands to just be ready for the use is going to be Bayes plot. And the other package that we have to just install before we move on, it's going to be ggplot2. If we have these two packages installed and ready to use, let's continue to see how can we just do some kind of simulations. In the original datasets that we had, you remember the thing that we did was that we had the women's data, we had the women's weight on the x-axis, and we had women's height on the y-axis. And the y-axis was essentially our response variable that we were trying to have a function which predicts and models the women's height with respect to the woman's weight. That was the simplest model that we could have thought of. And now, in order to just do that, I'm just going to go ahead and just start by doing some simulations as it was intended to do so. You remember the previous thing that we did was that we just had a model. It was called model A. And if you remember in the model A that we had, we just made that prediction. You remember, I'm just going to just type model A. And you remember, based on the model A that we did, we just used the Gaussian family in order in the Bayesian statistics to predict the heights from the weight. And we had 15 observations, which essentially showed that we have 15 women, 15 observations, which we had two predictors. One of them was the women height, and the other one was the women weight. You see that also that was the thing that we did before. And now, the thing that we just want to do, you remember the women's weight that we did, the woman's height, which we had it from the 58 pounds, 58 inches to the 72 inches. I'm just going to go ahead and store them into a separate object, which I'm just going to call that object, it's going to be called Y. It's essentially, it's a vector which I created, which includes all the observations which I had representing the woman's height. The other thing which I'm just going to do, I'm just going to go ahead and just go ahead to just use this function, which is going to be the posterior predict within the rstanarm package, which we have installed that from, I should say, in the couple of tutorials before than this one, because we were doing all the Bayesian regression analysis at this stage just with the help of this package, which is rstanarm. If we just call this function, which is posterior predict, and you just go ahead and press F1 next to, I should say, that function to have the help menu open, you see that on the help menu, you have a basic description of what is a posterior predict function, which it says that essentially it's a kind of a sampling method which draws, I should say, random, I should say, observations from your posterior distribution. And if you are wondering what is posterior distribution, you can think of the second intuition that we had, that you are acting as a Sherlock Holmes and trying to, base on the investigation that you are running, and based on the new updates that we get, it becomes as an updated priors to make some kind of, I should say, the prediction about who is going to be the potential and the suspect murderer. And now that we have, I should say, the posterior predict, which essentially it's a sampling, and the drawing from the posterior prediction, you see that what kind of arguments it's essential that we put that into our argument, into our function. The first one is going to be the object. The object is going to be the model that we have created in the Bayesian framework, which we just call that model A. You could have called that anything, but we call that for our purpose and illustration, we call that model A. The second arguments that we need, and we can just put that over there. It's going to be the rows. It means the number of the rows that you're just going to take. Rows. You can come with any number that you want. You can also scroll it down, and you see that. For example, the help that you have for the rows, it's essentially an integer indicating the number of the rows to return. And now, for the demonstration purposes that we have, I'm just going to go ahead and put that with the 600. That's an optional number, but you can just come with any numbers you want. I just go ahead with the 600. Before I just execute that line, I'm just going to go ahead and I'm just going to store that into an object. And I'm just going to call that woman posterior. Woman posterior. I'm just going to name the object woman posterior. You can call it anything else you want. And now the line is ready. The code is ready to be executed. I'm just going to go ahead, press Control Enter to run that code. It says that it cannot find the function. Let me go ahead and just install that package again. Maybe in some stages I do not have rstanarm. Let's see what is wrong with the code. I just go ahead to the packages which I have. Let's go that if I have rstanarm ready to use, because that function comes inside that package. And you see that the rstanarm, which is the Bayesian applied regression modeling via stan, is not, I should say, there. Then I'm just going to go ahead and I just put the library command and I put rstanarm, and let's execute that line. And you see that the rstanarm in the package tab which I have on the global environment, you see that it has a tick next to that, which it means that the package is now ready to be used. And now, if I come here and just try to execute that line again, if I press Control Enter, you see that the object now is created, because right now I have the posterior predict function, which is inside that package rstanarm is ready to use. Then now, I have the woman posterior datasets. The woman posterior object is created, and if we just want to see what is the class of the woman posterior which you have created, you can just go ahead to execute that line. You see that the thing that you have created is a kind of a matrix, an array. You can just come here to see that what is the dimension of the woman posterior object which you have created. You see that it has 600 rows and 50 columns. You can just investigate further. You just go ahead with the line of the head, with the code of the head. With the woman posterior, then you can have only the 5 first rows of that object to be displayed. You see that? It displays the first 5 rows, which it shows that, for example, the rows which it had. For example, for the first, you see that it's a 15, I should say, columns. Each column represents any woman's in our data sets, because if you remember, the woman data sets, I'm just going to go ahead to show that to you. You see that if I just go ahead with the dimension of the woman data sets that we had, you essentially saw that we had the same thing. The dimension of the women data sets, it was 15 rows and 2 columns. Each rows represents one woman, and each column represents the weight, and the other column represents the weights of that woman. And also, when you just go ahead and just you draw, for example, the first 5 rows of the object, which is the woman posterior, you see that still you have 15 columns. Each column represents one of those observations, which each observation in this type of data sets is going to be a woman. We have 15 women, and we have 600 rows. It means that for 600 in the parameter spaces, we sample from, I should say, a posterior. And each sample which we have taken, for example, it just came with one, estimates for the height of each woman. For example, you see that, for example, if I just go ahead and just write, for example, y, which it was a woman's weight, you see that for the first woman, the actual and the real height of that woman was 58 inches, and you see that on the first sampling on the posterior distribution, which essentially it comes with an update of the woman's height, we have 58.72 for the first woman. The second row, it gave us a 15, came up with 59. The third row, the third sample from the posterior distribution, it came with 59.60. The fourth row, each row means, for example, one attempt, one sample to just dive into our posterior distribution and read what is the predicted, for example, the height for that woman based on the model that you have created. You can go ahead, you see that, for example, on the first attempt, or the first row, or for the first sample, or the first investigation which you had. For the fifth one, you read, for example, 59.94 inches for the first woman. And essentially, that's what we think of these rows, which we have from our data sets. Okay, so far so good. You can also go ahead, for example, go to observe the first 100 rows. You see that, for example, for the first woman, it goes with the different values that you have. Each sample represents one row, or each row essentially, in a very lame term to use, means that one deep diving into our posterior distribution and to read what model predicts for the first woman's height. Okay. So far that we have done this so far, it seems that we have done a great job, and now we just move on to the next stage of our, I should say, intuition, and just working with our data sets, which essentially is going to be using the Bayes plot to visually and graphically compare what is the actual height of these women's and what is the predicted values of the height from our Bayesian regression analysis that we have proposed. We are going to do that on the next tutorial, that we just have some kind of energy left to continue and just not to get bored by sitting behind, as she said, the computers there. Then on the next tutorial, what we are going to do is come here to graphically visualize and compare these posterior samples with, or I should say, with the actual height of these women.